Hi C Block, so we're going to attempt our first virtual classroom lesson. So it comes from section 6.2 in the book. I'm going to do about half of it today. I'll post some practice problems for you to try and then try to finish up the section tomorrow. So the whole section is on properties of exponents. So we're going to look at the first few properties. The first property we're going to talk about comes from the base 10 system. And the base number I'm talking about is your main bottom number raised to some exponent. So if I have a base 10 to the power of 1 or to the first power, you guys know that that's just 10. 10 to the second power means 10 times 10 equals 100. 10 to the third power, 10 times 10 times 10, that would be 1,000. And then 10 to the fourth, 10 times 10 times 10 times 10 would equal 10,000. So do you guys see a relationship with the exponent and what we get for an answer? Or a relationship with the exponent and how many zeros are in our answer? So one exponent has 1 0, or the exponent of 1 has 1 0. Exponent of 2, our answer is 2 zeros. Exponent of 3 has 3 zeros, and so on. This pattern would continue. Again, this only works for the base 10 system. But what I want you to think about, what if we were to work backwards? So we started with 10 to the first. What if we actually started with 10 to the 0 power? What do you think that would equal? Remember, 10 to the fourth had 4 zeros, 10 to the third had 3 zeros, 10 to the second had 2 zeros, 10 to the first has 1 0, 10 to the 0 power would have no zeros. It would just equal 1. So our very first property of exponents has to do with this right here, the 0 power, the 0 exponent. Anything with a power of 0 is going to equal 1. So if we had 2 to the power of 0, that would equal 1. I had 54 to the power of 0, that would also equal 1. I had a variable to the 0 power, that would equal 1. Anything to a power of 0 is equal to 1. Why? Because of the base 10 system. So again, if I continue working backwards, 10 to the fourth, 10 to the third, 10 to the second, 10 to the first, 10 to the 0 power, what would be the next one? It would be 10 to the negative first power. Any ideas what that would equal? Kind of look at the pattern here. We left off at 10,000. When we moved back to 10 to the third, we lost a 0. Then I lost another 0. Then I lost another 1. So I don't have another 0 to lose, but losing a 0 is the same as moving the decimal place over once to the left. So if I'm at 1 and I move my decimal place over once, I get that, which is equal to 1/10. In decimal form, or in fraction form, I can write 1/10. So 10 to the negative first power is 1/10. Just need some more space here. So when you have a negative exponent, you can make, or you can get rid of that negative exponent and make the value of the expression you're writing positive by moving that base number to the denominator. Let me show you with another example. If I had 2 to the negative first power, I can rewrite that in fraction form with a positive exponent. I put 1 in my numerator, and my base number moves to the denominator. And my exponent, if I took like kind of the absolute value of that, it's 1. So I could put a 1 here with the base of 2, but 2 to the first power is just 2. If I had an exponent higher than negative 1, or say 3 to the negative fourth power, you know what that would become? I can move my base to the denominator. It's 3 to the fourth power. 1 over 3 to the fourth power, sorry. If I had x to the negative 7th, that that would become 1 over x to the 7th power. So negative exponents can be rewritten as positive exponents if you move them to the denominator. But what if I had an expression where the negative exponent was already in the denominator? Let me get some more board space. So if I had 4 to the negative third written in the denominator, if it's already in the denominator, we can take the reciprocal. This is equal to 4 to the third power. Same applies for variables. If I have y to the negative second in the denominator, then that is equal to just y squared. So the first two properties we just went over are 0 exponents. Anything to the power of 0 will equal 1. And then negative exponents, we can rewrite them so that the base will now have a positive exponent. The next part is, what if we have an expression, say 3 to the 2nd power, we want to multiply it by another value with the same base, so say 3 to the 4th power. Rather than multiply out 3 squared is 3 times 3 is 9, and then 3 to the 4th power, 3 times 3 times 3 times 3, which is 81, and get a big answer, we can just simplify this expression using exponents. I'm going to write out in expanded form what I kind of just said, but 3 to the 2nd power is 3 times 3, 3 to the 4th power is 3 times 3 times 3 times 3. If I were to multiply all these together and rewrite that with an exponent, I have 1, 2, 3, 4, 5, 6, 3. So that's 3 to the 6th power. Can you see what I kind of did with my exponents to get this answer? Can you see kind of a shortcut rather than have to write it out and see it in expanded form? 3 to the 2nd power times 3 to the 4th power is just 3 to the 6th. The rule is, the property rule for exponents, if you have the same base number, you can just add your exponents. 2 plus 4 is 6. And again, the same thing would apply with variables. So if I had x to the 3rd times x to the 4th, some of you could probably tell me right now what that would simplify to be, but just one more visual. X to the 3rd is x times x times x. X to the 4th is x times x times x times x, and I'm multiplying these two together. So this whole expanded form can be simplified to x to the 7th power. Or, as the property states, 3 plus 4 is 7. So it can simplify to x to the 7th power. So that's how you multiply numbers or variables that have the same base with exponents. What about dividing? What if I had 8 to the 4th divided by 8 to the 3rd? So again, we could expand it out and see what happens. 8 to the 3rd. If I were to divide that, well, we can cancel out anything divided by itself. So I'm left with just 8. What do you think the rule is? What did I kind of do with my exponents? I had a 4 and a 3 for exponents. Over here, I didn't even write an exponent, but the exponent really is just 1. So the rule when dividing by the same base, you can subtract the exponents. What do you think y to the 10th divided by y to the 6th would be? If you got that, you're right, because 10 minus 6 is 4. And I could write out 10 times 10 times 10 times 10 times 10, 10 times. Oh, wait, scratch that. I could write out y times y times y times y times y times y 10 times and divide it by y times y times y times y times y times y. And if I cancel out anything that they have in common, anything divided by itself, then I'd be left with just 4 y's. All right, so I hope those few examples are making sense. I have one more property that I want to share with you today, And again, I have these notes that I'm going to post in Google Classroom, and you can kind of follow along these examples as you look at the notes. But the last property is, what if you have a base number? So let's say 4 raised to the 3rd power, and all of that is raised to another power. So we call this a power of a power property. What do you think would happen? Well, 4 to the 3rd is this, and I got to do it 2 times. So there it is for the first one, 4 to the 3rd, times another 4 to the 3rd. I have 4 to the 6th power, because I have 6 4s listed here. So the property states, when you have a power of power, you just multiply the 2 exponents. That's different from this. When it's a base times that same base, but they have different exponents, you add the exponents. So that would be 4 to the 5th. But if it's a power raised to another power, so the 2 powers are right next to each other, the property states that you multiply the exponents. And then sometimes you might have negative exponents. If I had 4 to the -2nd raised to the 3rd power, well, -2 times 3 would be -6. And we got to use our negative exponent rule. We can make that positive by moving it to the denominator. So take a look at the slides along with these examples, and I'm going to have you try some of the problems and let me know how you make out. You can do the problems on paper and email me your work, or if you want to just do the work on Google Docs and share me your answers. Either way is fine. Good luck, and I'm here to help if you need it.